All right, so question number one. It's a function that has a polynomial on top and on the bottom of a fraction, also known as a rational function. We know the domain of this function, even though we're not explicitly asked, is going to come into play throughout. And so the domain is where the denominator is non-zero. This means we have to remember how to factor. X minus 7, x plus 1 equals 0. That means x is not equal to 7, x not equal to negative 1, right? For good measure, let's also note that the numerator can be factored as x times x minus 7. That's going to give us some insight as far as both asymptotes as well as discontinuities, right? So we know we have discontinuities at both places where the denominator is 0. X is equal to 7, we know is going to be a place where there's cancellation, right? And so since we have x minus 7, x minus 7, x plus 1, in effect, we're going to end up having cancellation right here. And so therefore, as long as x is not equal to 7, this is equivalent to this. This will have a removable because the x minus 7 factor was removed at x equals 7. Okay. All right, so what remains is identifying the other discontinuity, and we know it is infinite discontinuity, right? Because you end up with x equals negative 1. Right here in the denominator, that does not get canceled out, right? So that at the same time corresponds to a VA, right? At x equals negative 1. The limit as x approaches negative 1 of x minus 7x over x squared minus 6x minus 7 is equal to the limit x approaches negative 1 of x over x plus 1. If we approach negative 1 from the left, then that's negative over negative. So I'll say from the left, and that's equal to positive infinity. That's all we need to verify it's a vertical asymptote. For horizontal asymptote, we need to take a look at the limit as x approaches infinity of x squared minus 7x over x squared minus 6x minus 7 is equal to the limit at x goes to infinity of x over x plus 1, right? The factored out version, which using L'Hopital's rule is the limit x approaches infinity of 1 over 1, which is 1. So our VA is y is equal to 1. Alrighty. So these are our asymptotes. Next, we want to go ahead and find the limit as x approaches 7 in two ways. The limit as x approaches 7 of x, the limit as x approaches 7 of x squared minus 7x over x squared minus 6x minus 7. Okay, knowing we get 0 over 0, we want to F, E, R, and C. Factor, expand, rationalize, combine. In this case, factoring is the way to go, but we already did that. And so we know this is going to be equal to the limit x approaches 7 of x over x plus 1, which is 7/8. The second way is we can use L'Hopital's rule, right? We know we can get 0 over 0. So it's going to be the limit as x approaches 7 of 2x minus 7 over 2x minus 8. DSP it again, and we get 7/8. All right. Next question. We want to find the derivative in 3 different ways, right? And as you can already see the theme of doing things in multiple ways, which is something that I definitely will be testing on. X plus h minus f of x over h. It's going to be limit x up. Oh man, it's late at night. Limit h approaches 0 of 1 over x plus h quantity squared minus 1 over x squared over h. Plug in that h, you'll get a 0 over 0. Okay, so we're going to FERC, and the place to be, factor, expand, rationalize, combine. Factor, we can't. Expand, definitely not. Why? Because those are denominators. We do not expand denominators. Rationalize, I don't see square roots. We are going to combine. Okay. And so the way we're going to combine this is by finding the least common denominator by multiplying by the same factor on both sides. Okay, so I'm going to spell out over here to the right and say I'll put an x plus h squared, x plus h squared, x squared, x squared. And then what we end up getting is the limit h goes to 0, x squared minus x plus h quantity squared over the same denominator over h, but we already know that's going to do that, right? Okay, so we get limit h goes to 0. I'll have an x squared minus 2xh minus h squared over all of that. I know it's really tempting to expand that out. We're not going to do that. It's against the law. Okay. So let's keep it moving. So this is going to be all right. This is going to be equal to the limit. That's why I need an iPad. Limit as h goes to 0. This limit as h goes to 0 of negative 2xh minus h squared all over x squared, x plus h squared times h. Okay, and as always happens, we can factor out the h from the numerator. Minus 2x minus h over x squared, x plus h squared h. Now that h is going to cancel with that h. And so we just end up, after we plug in the 0 from the limit, with a negative 2x over x to the 4th minus 2 over x cubed. Alrighty, rule number 1, we know should be the power rule. Okay, because f of x is x to the minus 2, f prime x is minus 2x to the minus 3, minus 2 over x cubed, they match. The next rule, let's go ahead and make that the quotient rule. F is 1, g is x squared, f prime is 0, g prime is 2x. F prime g minus g prime f over g squared is what we're looking for. That's going to be 0 minus 2x over x to the 4th, which is negative 2 over x cubed. So it all matches.